Okay, to everyone watching out there, keep your chin and hopes high and be happy. So, starting from where we left off in the last video, this is the equation that we got of the linear equation, that on like what equation does it work. So, if we write this equation again, and we'll use some different color this time so that there will be no confusion. Okay, let's start from the new page. So the equations that we got is y equals to mx plus c, where x is the uh, petrol price and y was our average cost of vegetables per kg, and this was our slope, and this was our c was our intercept, m was our slope and c was our intercept. Okay, so we know the petrol price, and for the trading purpose we know the average cost of vegetables per kg. It is given in the data set. So to fit our model needs to know the accurate value of m and c. So suppose this is a graph. Okay, let me use some other color this time. So suppose this is a graph. Here it is the petrol price here, and it is the price of vegetable. I'm not gonna write average price, so if you can understand price of vegetables. Okay, and we got a straight line this, and the data point that was near was something like this. Okay, so this line tries to fit as many as data points that it can get on this straight line. So suppose let us consider just one data point, and just one data point. Okay, because in this way you'll get to for you it will be easier to understand. So suppose this is a line and we just have one data point. Okay, and for that it is the petrol price and it is the average cost of vegetables per kg. So if we for the given petrol price, okay, we got to know that we have predicted that our vegetable price would be this. Let's consider this as x, and let's consider this a y dash. Okay, this y hat, and this is actual price of the vegetable. Let's consider as y. Okay, I know it's quite like mishap here, so let's take another graph. Okay, sorry for that. There will be just one data point. Okay, this is our data point. Okay, so for a given petrol price, okay, we have predicted our vegetable price to be this. Let's consider this as y dash. Okay, and this is our actual petrol price, and let's call this as y. Okay, so if we consider this error, so we have this much error. This is the amount of error that we have got in between the prediction and the actual result. So our data should be as close as to the actual result, but we got the error in the prediction. We thought we got y dash as our value. So if in the linear regression the error is calculated as error equals to y, that is the actual output, minus y bar का whole square. In other words, error is equals to actual output minus predicted output whole square. Okay, so if we decompose this further, break down this further, so the actual output we have is y. If you can see from the graph, here is our y value. This is the actual value we have, and the y bar that we have is given by this line. Okay, just a second. This line is a predicted value. Okay, this whole line is a predicted value. Okay, so its equation is given by y equals to mx plus c. Y bar equals y bar equals to mx plus c. So if we do mx plus c and if we put it whole square here, okay, so error will be calculated as y square minus mx plus c whole square minus 2y mx plus c. Okay, breaking it further down, so error is equals to y square plus m square x square plus c square plus 2 mxc minus we'll multiply this here, 2y mx and minus 2yc. Okay, so if we write down further the error value, so error is equals to y square plus m square, I'm writing this value again, c square plus 2mxc minus 2ymx minus 2yc. So this is okay, so this is our error term that we have got. So we need to reduce this error as much as possible. So we cannot what we can do, we can only configure or change m value and c value here, so that our error can be reduced. But because x is already given, x is the data that is already given and we cannot manipulate it, and y square is the actual output that is given in the dataset, we cannot manipulate it. So the only two variables that we have here is m and c, and m and c are called hyperparameter. So whatever the machine used to calculate, those values are known as hyperparameters in machine learning. So, okay, so we will calculate m and c, and we will get to know how we can find m and c in the next video. Stay tuned.